Good morning, grade sixes. Welcome to STEM Lockdown Digital School. It is so awesome to be back this morning. Thank you for all the good morning wishes. It's so nice to be back, and good morning to you. I hope that you're all nice and comfortable and you're all nice and wide and awake. And although the weather on my side is sleepy time weather, I will try not and fall asleep while I'm teaching you. So remember to keep chatting in the chat box so that you keep me busy talking. Okay, now I do know that yesterday I think I spoke a bit too fast. So I'm going to slow a bit down today and also give you time to take some notes. Now, I am going to cover a little bit of what we did yesterday, just to review it, okay? And just to clarify certain points, okay? Now, I'm just better introduce myself first for anybody who is new. I am Sheena Cooney, your teacher and presenter. This is my email address for your homework, should you want to send it to me. Now, the homework that I did put up is revision of what we were doing with solids, liquids, and gases. So the first part is just some notes and revision. The second part of the homework I gave you was just to draw some particles, okay, of a solid, liquid, gas, and to complete a table with the different containers. So it's not a very difficult activity. So I thought it would be a nice one for you to do. So you must go check it out, and you can email it to me, and then I can at least give you some feedback. It's okay if you haven't done it. It's a new week, and I know that we've probably got to get back into it, and you've got to get used to your new teacher as well. So I do understand that. So welcome to anybody who's just joined, and anybody who's new, and anybody who doesn't know me. It's really nice to have you back again. So what we're going to do is we are going to just go over the properties and complete the discussion. Remember, we started talking. Welcome, JD, Zany. Sorry, I've got to remember all the names still. I still got to practice them. Okay. So we started yesterday with talking about solids, liquids, and gases separately in a bit more detail. So I'm actually going to start where we ended yesterday. And we're also going to touch, welcome Kiara, thanks for reminding me. We are also going to do the 3 states of water. So it's going to be nice and hopefully easy for you to understand in today's lesson. So as you know, we discussed yesterday about the solids and the liquids and the gases, okay? And I got some very, very good feedback and descriptions from you guys, which was really, really awesome. Now, there were also some very good questions that I got yesterday about the solids and liquids and gas, and some of them were quite interesting. So, Michael, you said you want to ask a question about yesterday, and I didn't see it. So, please ask the question. I'm reading the chat now. I'm sorry if I didn't see it yesterday. Just type it in there, and I'm going to do my best to answer you. Okay, is fire a liquid or a gas? All right, class, grade 6s, what do you think? Are you able to answer that question? And why do you think so? It's a gas. Why do you think it's a gas? Any reasons why you think it's a gas? I've got a lot of gases saying it's a gas. Okay, you can't touch it because it takes up a small amount of space, because it can't take the shape of a container. It can't be liquid because it's not watery. Okay, so that is very true. Fire is a mixture of hot gases. Okay, so the flames are resulted because of a chemical reaction between the oxygen, the air that we breathe, which is a gas, and fuel, like wood or propane. So it reacts to the oxygen in the air. As you know, I don't know if you know that when there is a fire, do you notice how that when there's wind, there's a lot of warnings going out, because wind is also, it's not water, it's not a solid, it's also a gas. And it carries the oxygen around as well and flows it. It causes an airflow, actually, that kind of fans the fire. Okay, so smoke apparently is solid particles with some gases. Okay, but that is when we get a bit into more detailed. So you say there's a white thing in your way. Okay, well, hopefully we can move it out your way. All right. So it's kind of like, some people think fire is a solid because it touches on wood, right, and oil, but it is actually a gas. Okay, so let's review a bit. And I really like some of the answers that you remembered. What I've got on the screen right now is a very, very brief summary. But if I had to explain it in more detail, please let me know if you can hear me, because might mention something that is not on the screen, and you can ask me to repeat. You can also jot it down. Now, there are a few properties of solids, liquids, and gases. Okay. And the basic ideas, actually, you know what? I'm going to show you. I do have it here. Ha! I did not realize I had it here. Okay, so these are the notes we started with yesterday when we started with solids, remember? And I tried to get you to imagine if you could shrink yourself to the size of a particle and imagine what you see around you. Okay, so that is what we did yesterday. And the one important thing that we did notice, that the solid is packed very tightly together. So it takes up a definite space. Can you see that? It takes up a definite space. So it's packed very, very tightly together. The second thing is you cannot squeeze it into another shape. It can't be compressed. If you design it to be a certain shape and size, that's what it's going to be. Now, I do remember someone asked about, what was it? It's squishy stuff, slime. Okay. Now, yes, if you had to get really technical, slime, who said gave me the details about slime yesterday? Do you just want to reiterate those details for me? Yes, I do use Thunderbolt Kids because when you are doing an online teaching, you can only use certain materials because a lot of materials are copyright. So we have to obey the law in that way. So a lot of my notes, yes, they do have to come from those books. So that's a very good question. Now the slime. So who mentioned the slime? You said very good. Okay, Shakira, is that your name? Or I haven't got my book in front of me. Sorry, apologies if it's not your name. Okay, so Shakira, I think, yes, it is your name. Non-Newton, you said Newton liquid fluid. Okay. And then what else did you, I'm sure you said something else. If you have the books, then it's actually easier for you to follow. But my notes, remember my notes do not all directly come from the books. So when we do homework, you must still try and go on there and see if you can work through the notes, because they're not directly from Thunderbolt. They're my own notes, a lot of them. Okay. So slime is a non-Newtonian liquid. Okay, that basically means that it is a liquid that you can kind of like move around. All right, now remember yesterday I said it was a solid, because if you smack it or if you put your hands on it and flatten it, its surface is like a solid. It looks like all the little particles are close together. So I think that your answer is correct, because we should call slime a liquid. It might not be a liquid we talk about often, but water is apparently also a Newtonian liquid. So if that's the case, if water and slime are both Newtonian liquids, then they're both liquids. So that will resolve that question quite nicely. I love it when you guys ask questions like that and give answers like that, because that is so cool for learning. It makes everything so much more interesting. And then we always learn something new, you know. Is fire a mixture of gases that we can put in a cylinder like other gases? Fire itself can't go in a cylinder, but the gases can. For example, look at a lighter. Okay, how do you think a lighter works? So if you know anybody who uses a lighter a lot, okay, so it needs oil to burn. It can melt anything at high temperature. Okay, so there is gas inside a lighter. Remember that. A lighter inside the container has gas. It's a butane gas. Okay. Now, it is different in the sense that when you turn the lighter wheel, you know the little lighter wheel, it creates a friction. Okay, and a tiny stream of gas is released from the container. And when you turn in that little wheel, it creates friction, which creates a spark. Okay, that spark lights the gas. Okay, but butane in that form is controllable. So it is a gas. It does not need oil to make it burn, because the friction, as you turn in that little lighter wheel, that friction is actually what lights the gas. Okay, so lighters are a very good example of gas to make fire. Okay, so because you can see when you light it, the flame actually comes out. So it literally is making fire with friction. So that's actually a very nice example. Okay, I like that question. Nicely done. Give yourself a pat on the back, because if I could, I would. Well done. Yes, it does create a tiny spark. Now let's go back to solids for a little bit. Although I absolutely love your questions, so please don't stop. Now, it seems to me that you have a very good idea of what solids are. Okay, so let's go on to liquids that we are busy discussing as well. Okay, now water. We were talking about water as a Newtonian liquid, which is quite interesting. I absolutely love that you brought that up. Now, water, when you put it in a mug or in a glass, or even if you look at water in a pool, a body of water, do you notice that oftentimes it looks very still? Even when the only time you kind of see it move is when the wind or something like drops into it, or you skip a pebble across the water or something like that. However, water looks very still. Okay, so are you with me still? I'm not talking too fast, am I? Okay. Now, water particles, this is very, very interesting. They are constantly moving. You just don't see it. You just don't see it. So, oh, I'm getting some nice, interesting questions here. I love it. It's absolutely brilliant. Okay, so water can look still, but the particles are continually moving. So that's an important point. So I hope you do have that one down. If you have the book and you have those notes, it's also fine. I just want you to be able to keep track. Okay, so you say that toothpaste is a liquid because the particles are tiny. Okay, are they close together or are they compressed? How would you describe toothpaste as? Okay, so someone says, okay, I'm still waiting for a few answers. One says that it's a liquid. Do you know what? Okay, toothpaste, if you had to break it down, is actually made from a powder. So if you're to look at a powder, what would you consider a powder to be? Is a powder like a liquid or is a powder more like a solid? What is powder? It's more like a solid. Okay, so when you mix powder with liquid, it becomes toothpaste. So therefore, it's like flour. Have you ever taken flour when you're baking and mixed it with water? It becomes like a paste. That is why toothpaste is a solid and a liquid. We are going to get to mixtures. You guys are really jumping ahead, but that's good. So that is when we do mixtures, which we are doing tomorrow. Okay, so then we'll talk about mixing the substances because they can be mixed. All right, but if you break it down, then yes, then you can identify that parts are a liquid and parts are solid. Now, if you have learned this is absolutely awesome. But for those that we're revising, please remember this is a revision week. So I really need to ensure that before we start grade term 3 work, that we kind of make sure we revise what we know. Now, I'm going to tell you something that you must remember. If you are learning something or being taught something, whether it's in the classroom or whether it's here with me, and you feel like you've heard it too many times before, or if you feel like, oh, this is getting boring now because I know this, that is such a good thing. That is such a good thing because that means you know that you know that you know that you understand. All right. So I have some awesome pupils here that are sharing some very, very nice links as well, that can help you out. But the only way to really understand it is also to practice drawing the pictures. Now, in science, as you know, we do a lot of drawing. So if you're drawing the particles, which is also part of the homework, then you get a better idea and you're able to do it in any of your tests or assessments or in your classroom. Okay, so thank you so much for arriving. If you're a bit late, don't worry. You won't miss anything because I do a summary. Okay, so what we're going to do is we are going to do assessment hopefully on Friday. Maybe I'll do it through Kahoot. We'll do it that way. Okay, but then remember the rules for Kahoot, that you need to all work together to do it properly. Okay, because remember, you guys have to help me because Miss Cooney or Miss Sheena or whichever you'd like to call me has not done Kahoot on this platform before. So you are going to have to guide me. Okay. Now, is it Adele? you want to take notes. Did you not have these ones yesterday? Okay, so everybody's going to jot this down. If you have it, that's fine. But I would like to give those who don't have it time to write it down, because it is important to know that liquid particles are very close together. They cannot be compressed like solids. Okay, they're always moving. They do not have a fixed position, but it still flows because they're constantly moving, and they can take the shape of the container, but they can only take the shape of however much volume it is. Okay, now would the class be okay if I went back to the previous slide and let some of our learners that have just arrived take notes, or that weren't here? Okay, because this PowerPoint is online. It's on our website. Okay, it's on #lockdown eSchool or African Teen Geeks. You will see it there. All right, so this very PowerPoint will be online for you. Okay, I have actually pre-recorded this PowerPoint for you, so you will have it. All right. Okay, so don't be sorry. I'm going to stay on this slide, but can I carry on talking while you're on the slide? Is that okay, or will it distract you? All right, so visibility, shape, space, and flow or movement are your different properties. Okay, now solids, when it comes to visibility, they are easy to see, right? Liquids are also easy to see. However, gases are not easy to see. So being able to identify the three, we can use what we see, our eyes. Shape. Okay, let's look at shape. Solids have a definite shape. You can tell if something is a car or a chair or a building. You can easily tell that. It has a definite shape. Liquids, they don't have a definite shape because you can put it into any container and it will take that container's shape. So if I have a swimming pool, if I have even, like, think about this, you go to the beach, you got your little bucket, you put your water in it from the ocean, and you can see it takes the shape of the bucket. And then you go and you dig a hole in the sand, you pour your bucket of salty seawater in there, and it'll take the shape of the hole that you dug. So it has no definite shape. Gases also have no definite shape. All right, and we cannot see them, so they really, if you don't contain a gas, he's like a naughty child. He'll just go everywhere like a toddler. You have to like keep a lid on it, otherwise it's just going to go everywhere. And we need that, especially when we're talking about air to breathe. All right, now space. Take up a definite space is solids and liquids, but not gas. Gas only takes up space that's available to it. So, for example, when I said earlier that we put gas in a lighter, the lighter container is the only available space we actually made for it. So it can only take up that space. But now, if I put that little switch down on the lighter and to release the steam, the gas, the stream of gas, then it could all escape. Okay, a sponge, we are actually going to talk about the sponge because the sponge is quite important. When we talk about the wetlands, we're going to talk about the sponge. That is coming up. Okay, so I am going to talk about the sponge. What the question you asked, I just want to get through the basics first. We want to lay our foundation for those that don't have it. If you do have it, you're awesomely patient, and thank you so much for being with us. So our flow of movement, right? You have your solids, they do not flow, okay? You have your liquids, they can flow, and gases can flow. Then you have your examples. You must be able to give example, which is fairly easy to do, I think. It's only when you get in the higher grades that you have to kind of like really think, because obviously it'll be more scientific. Now, who remembers in the beginning what I said small particles are made from? Who remembers what I said in the beginning, what small particles are made from? Right in the beginning of our slide yesterday. This is for those who want to jot this down. Ah, yeah, I'm okay. I'm just wondering, what did we, who remembers what we call the small particles? You remember? The tiny particles. If you have a scientific microscope and you're studying it under the microscope, what do we call them? The one starts with the A and the one starts with the M. Oh, shame, sweetheart. Are you not done? Okay. Yeah, you can take a screenshot quickly. There you go. You can take a screenshot of that, and then I'll go down again. So yes, excellent, guys. Well done. Atoms and molecules. Now, these are the particles that are way too small to see. All right, you need a really special microscope to see them. And there are three categories that these atoms and molecules and particles move in. And if we want to really understand it, we've got to look at the tightness of them. Can you compress them? And their position. And the only way we can see that is when we do these drawings. We can see them nicely. So this is the liquid slide. As you can see, you will need to, for your homework, I have put a worksheet up, draw the container to show the liquids. You see that they're not as tightly together as the solids, but there is not that much space between them either. Okay, they don't have a fixed position. See, they're all sitting wherever they want to. Whereas a solid are like good little children and will sit in their seat. Liquids are the busy children. They like sit wherever they want to sit, and which is nothing wrong with that because we need them to do that. And then the only way a liquid can flow is if we have them loosely together. Okay, now tightness. Can you tell me if something is tight, how would you describe the tightness of a solid? How would you describe the tightness of a liquid? And how would you describe the tightness of a gas? If I had to throw that word at you and say, okay, use this word to explain to me, what would you say? Let's get our thinking caps on. Okay, I'm on the liquid slide for those who need to jot this down. Okay, you can do that. I don't mind waiting. Okay, so tightness. Let me throw the word tightness at you. Describe a solid using my idea of tightness. If I had to say, classify this particle according to tightness, how would you classify a solid? How would you classify a liquid? How would you classify a gas? Any ideas? I think you're probably writing because you're very quiet. But that's awesome. As long as you let me know that you're writing, then I know to stay where I am. Okay, how are we doing with this, the liquid slide? Okay, this is the liquid slide. Okay. All right. So The most important things from this slide that you need to know is that they're very close together. They cannot be compressed. They do not have fixed positions, and liquids flow. Now, I've got an answer here for the tightness. Tightness is what keeps its shape. I do see hands up, but unfortunately we can't, I can't activate that. So they do need to type, unfortunately. It's the only way I can see. They do need to type just type in the chat, JD. I will wait for you and I will scroll back to your answer if more come up to your question. All right, so you are absolutely right. Tightness are particles that are packed tightly together. So that's for a solid. All right, what would you say about a liquid if we're talking about tightness? JD and Triash, just type your questions for me. I am waiting, it's fine. I don't mind answering questions on the chat. It is much easier for me to follow. Okay, the question is, if I had to give you the word of tightness, okay, how would you describe a liquid according to tightness? So I'm not throwing a normal word at you like compressed. I'm throwing a different word at you. Sorry, my voice is a bit going there. Okay, so tightness is when things are close together when it comes to a solid. But how would we say it when we come to a liquid? Okay, so, okay, JD, that's good. That's good. I like that. Very good, Melody. The particles for solid are squeezed tightly together. For liquids, you would say they are close together, but there are still spaces. Now, do you remember? I apologize if my dog barks. She's yeah, she's on guard duty. Right. So, here we go. What do you call the space between the liquid particles and the space between gas particles? Remember, there's a special, oh dear, I think I just gave you the word. Do you remember the word for it? It's okay, it's fine. I know that it's going to happen, especially on certain devices, you're going to accidentally click something. It's fine. Okay, so yes, it is not tight. It is further apart than solids. Do you know the one word for the space between them? Even this image here on the screen, if you see the space between those particles, what is that space called? Ah, well done. So the particles, yes, they would be called molecules, but the space between them would be called a vacuum. A vacuum. Well done. Right. So what we would see here is, yes, what we would see here is if you could go down, like yesterday when we said we'd shrink down and look inside a gas, what would we see? Now, you would notice as I'm reading the answers as I'm going, that the particles in gas are far apart. And you can see this bottle, the straw in here, it's got a lid on it, okay? Now, it has to have a lid because otherwise the gas would escape. Now, these spaces between particles when it comes to gas are huge. They are bigger than the actual particles. Whereas in the liquid drawing, they were almost like an equal amount of space. So yes, you are right, grade sixes, it is called a vacuum because those spaces are empty. Now, this is why we can actually compress a gas because of the spaces. The spaces allow us to move the gas into a smaller shape just by pushing them closer together. That is why we can compress them into small or large or cylinder-like containers. we can also make the spaces between them larger or smaller. Now, gas particles move freely, and in a closed container, they still spread out. Like, for example, liquid would retain its volume and only fill to a certain amount, a definite amount, but gases would just spread themselves out and fill the whole container, no matter which container you put it in. So if you want to contain its volume, you'll need to ensure that the size of the container is the size of the volume you want to contain. Now, an open container, as you know, they will escape. Okay, they flow out and they disperse and they spread everywhere. I don't know if you've ever just, I'm going to stay on this page for a moment for your notes. If you've ever had a gas fire or a gas stove, and you've lit it, you would get that smell of gas when you open the valve. Okay, so that's what gas does. It immediately makes its way to freedom. Okay, they do not like to be contained. So that is why you light it quickly, so that the gas gets caught up into a use like fire. All right. So, okay, so you got that now. Yeah, it does. It does smell bad. It's only harmful to you when it's not on fire. That's quite an interesting thought. So if you have a gas heater on, or if you have a gas stove on, you don't want the valve to be open. You want it to, you want to light it as soon as it's open, so that they don't flow out and disperse. Okay, I'm going to wait for a few of you because you are writing notes, and I'm glad. I'm actually very, very glad that you are writing notes and that you want to write notes. It really is a very, very good, well, how could you say it? It's a good work ethic. And it's worthwhile, because then you always have the notes for whatever you need to do. So please send me your homework. Go onto the website and check the notes that I've put up there for you. JD, this PowerPoint is uploaded and I've done a pre-recording, so you'll be able to listen to it, and you'll be able to go onto my slides and go back and forth as you want to, because we do have it on our site for you. As soon as we have this written down, maybe at the lesson, if we can, if we have time, we'll go back. If you want to take a screenshot, you just press, if you've got a laptop, you press central, and then you press the button at the top of your screen. It says PRTSC. So if you push down central and you push down that button at the top, then you can actually take a screenshot, and then you can copy it onto a page. It's not there yet because they have to just double check that everything's on the worksheet, homework worksheet, and it takes a while to upload because there's a lot of things for grade 6 up there. Okay, so I will get onto it though. All right, I'll find out if it's there, and I'll ask them to put it up. Okay, thank you for actually letting me know, because I need to know. So the site's name is Africa Teen Geeks. What you can do is, I'm going to continue this lesson. Don't disappear. I'm going to continue this lesson tomorrow. I just want to scroll down to the slide with all the questions you're asking me. If you look, yeah, we go. Oh, I've missed it. Look at that. Okay, so I'm going to go down to the last slide quickly for you. Over here, there you have it. #lockdown school. If you go to African Teen Geeks on Google, then you can actually find everything there. All right. Your homework or questions you can send to me. Even the questions you have now, you can send that to my email address. I'll answer you. Really, it's no problem. Yes, you do. You press Central, Alt, and PR. I didn't do the say the altar. Sorry about that. Okay, so here's my email address. Please write that down. Send me any questions you have. Honestly, I'm going to follow up for your homework, okay, to see that it's up there. Tomorrow, we're going to continue with this, okay. I am going to go back to that slide because we do have time. So we're going to go back. Yeah, I always do that too fast. How's that? This one, there we go. Okay, so for those of you that are busy on this page, right, you can continue to write the notes. For those of you that are leaving, please come back again tomorrow. It was really, really great to have you. And this is the gases one. If you can't do your homework, it's okay. Just please join me and join us again tomorrow when we do our lesson. Okay. For those of you that are leaving right now, thank you so much for joining our class today. I really enjoyed having your interaction and your participation. You guys are really good with that. So give yourself a pat on the back. And then I will chat to you tomorrow, same time, same place. Okay. So for those of you that are staying to write this down, I'm not going to move off this screen until you've got it down. So let me know when you do have it down. Okay, bye-bye, guys, that I've got this down. Thank you so much for joining me. I hope, listen, please give me any feedback. Okay, any feedback in a way I can help you. Okay, sweetie, thank you so much. Right, it's awesome to see your faces actually on the side there. It's pretty cool. Okay, so any questions before you love and leave me? Okay, anybody still writing this down? All right, Zamila, you said something about homework. Are you asking a question? Are you going, Sisibile? Bye-bye, sweetheart. Bye-bye, George. Thanks so much for coming. Oh, I love the smiley faces. I know we try not to have the videos on because it affects the streaming. The homework, what I'm going to do, there is homework on I have put up some homework for you guys, and I've dated them according to the day, Monday, Tuesday, Wednesday, Thursday. All right. So let me just scroll to that page that indicates the homework, but I did, you'll have to go to the actual worksheets to do that. So this is what we're going to do. We are going to practice drawings, and I've put some questions there about solids, liquids, and gases. And I've also put up an explanation. So you do have that explanation on there as well. Now, I know some of you said that you can't find it on the site. So I'm going to go and look to see if your homework sheets are up there yet, so that you can at least go and look at them. Blessing, welcome. It's fine if you're late. I'll see you tomorrow. Thank you so much for joining my lesson. We will continue with this tomorrow, okay? And then hopefully come ready with your questions, okay? Come ready with your questions. Send me an email with any questions or anything you want me to talk about, okay? If you're slow with writing, you know what, Adele? It's perfectly fine. I can be just as slow sometimes, so don't ever feel bad about that, okay? The homework, Samile, is not on the slide. This is just the instructions, okay? Kiara, sorry, sweetheart. So I apologize for that, Kiara. It's perfectly fine. Zamile, what I'll do is tomorrow, because you need to see the worksheet, and now that I understand that as this is a new class, I'll put them up on the slide as well, so you know what you're looking at. Would that help if I did that? Okay, I will do that for you. All right, join me tomorrow, same time, same place. Kiara, thank you so much for being here, and I look forward to seeing you tomorrow. Sisibile, bye-bye. Blessing, don't feel bad. We'll review it tomorrow as well. Awesome. Bye-bye, guys.